in this video I'm going to go through this particular chapter, which is from chapter 6 chemistry, which is the chapter related to acid, base and salt. So without further ado, let's get started. So let's look at the first question, which is which of the following substances that ionizes completely in water. So the first thing we need to know is that what is meant by ionize completely. So let's say today I have a solution A, and then when I put this solution A into the water, into water, it will ionize 100%, meaning that it can dissolve completely in the water. That's what it means by the ionize completely in water. So for the substance that can ionize completely in water, it must be very strong. The meaning of strong is that it refers to whether the substance is strong acid or strong base, since this chapter is related to acid and base. So let's go through the first option, which is the ammonia. So for your information, ammonia is actually a weak base, or we say weak alkali. So it cannot ionizes completely in water. So the term that used to describe the ammonia is that it ionizes partially in the water, meaning that unlike the strong acid or strong base, which can dissolve 100% in the water, for the weak base and weak acid, it can only ionize partially in water, which is roughly maybe 5 to 20%. Yeah, this is just a rough estimation. It's just how we describe it. So the hydrochloric acid is a strong acid. So it means that it can ionize completely in water to produce the hydrogen ion. For acid, it will ionize in water and produce the hydrogen ions. So the ethanoic acid is the weak acid, so it will not be the answer. And then for the sodium hydroxide, it is a strong base or strong alkali, so it also can dissolve in ionizes completely in the water. So the answer would be 2 and 4, and the answer will be C. Next, which of the following is a diprotic acid? So for your information, this kind of question is asking you the basicity of acid. As we know, we have three types of the basicity of acid, which is the first thing is monoprotic acid, the second thing is the diprotic acid, and the third is the triprotic acid. So this basicity is actually referring to how many moles of hydrogen ions that can be given out when 1 mole of the acid dissolve in the water. So this is the definition. So we need to know, so for diprotic acid, this is di. Di means 2, means that it can produce 2 moles of the hydrogen ion when 1 mole of the acid dissolve in the water. So let's look at the option one by one. The first thing is nitric acid, which is HNO3. So this is a monoprotic acid. And then for ethanoic acid, it also releases 1 mole of the hydrogen ion when it dissolves in the water. And then next, for C, sulfuric acid, which is H2SO4. This is a diprotic acid. This is one of the famous examples for diprotic acid. And lastly, for hydrochloric acid, it is the monoprotic acid. So A, B, and D all these three acids will give 1 mole of the hydrogen ions when it dissolves in the water. So this answer would be C. Actually, there is a hint that can let you know whether this acid give how many moles of the hydrogen ion. So this is, when you see this is H2, so means that it will give 2 moles of the hydrogen ion. So let's say we can write the equation like this. When it ionizes in water, it will give 2 moles of the hydrogen ion and 1 mole of the sulfate ion. But maybe some of you will wondering, like, is it ethanoic acid can give out 2 moles of the ion? The answer is no, because this is a weak acid. So it will not ionize in the water completely. So we cannot know whether there is how many moles of hydrogen ions that were produced by the acid. Okay, the next question. What is the triprotic acid? So now we want to find the acid which produces 3 moles of the hydrogen ion. So let's go through the option one by one also. So A, nitric acid. The chemical formula is HNO3. And then the phosphoric acid, which is H3PO4. C, sulfuric acid, which is the diprotic acid in the previous question, and hydrochloric acid, which is the monoprotic acid. So the answer would be B, which is the phosphoric acid, as it can produce 3 moles of the hydrogen ion with 1 mole of the phosphate ion. Hi, so let's continue with the discussion. So this is the questions which ask you which of the following substance will produce the yellow color when the universal indicator is added to it. So the first thing you need to know is that what is actually a universal indicator. So for information, universal indicator is actually a chemicals. So more details about it will be a mixture of either the weak acid or weak alkali. So this thing, it actually doesn't matter for the definition, but the thing is that you need to remember the color changes. So let's say in this question is asking what is the substance that will produce the yellow color, means that the universal indicator at first does not has the yellow color. So it must be from one color change to the another color, which is the color yellow color. So for information, universal indicator, when the pH is neutral, means that when the pH is 7, it will be in the green color. But when the pH is kind of like less than 7, which is the acidic solution, it will turns into yellow color or orange, depends on the solution that you want to test. And then when pH is more than 7, which is the test solution that you want to test is actually alkaline, so it will become blue, dark blue, or even purple color, depends on the concentration of the acid or alkaline. So since we already said that when pH is less than 7, so the universal indicator will turn from the green color to the yellow color. So in this case, we need to choose the answer, which is C, because for A, it is actually not acid, also not alkaline. For B, it is slightly acidic. So for information, the blood, let's say for human blood, the pH is almost 7.2 to 7.7, which is kind of like slightly alkaline. And then C, tomato is a sour, so it will, when it dissolves in the water, it will produce the acidic solution. And then for lastly, D, salt is actually an alkali. So this answer will be C. Okay, next. Which of the following acid correctly match with their basicity? So in the previous question, we also already discussed about what is the basicity. So basically, you need to know when you come across this word, which is the basicity, you need to know directly it is asking the monoprotic, diprotic, and triprotic acid. So monoprotic acid means that 1 mole of the acid will produce 1 mole of the hydrogen ions when it dissolves in water. So same goes to the diprotic acid. It is when it is produced 2 moles of the hydrogen ions when 1 mole of the acid will dissolve in the water. And lastly, for triprotic acid, it will release 3 moles of the hydrogen ions per 1 mole of the acid when it dissolves in the water. So in this question, it is asked for the monoprotic acid and diprotic acid. So 1 and 2 hydrogen ions. So the very popular examples for diprotic acid is actually the sulfuric acid. So you only need to look at the option C and D, phosphoric acid and the hydrochloric acid. So the answer would be C, which is the hydrochloric acid, because it gives off 1 mole of the hydrogen ion when 1 mole of the acid dissolves in it. And then for phosphoric acid, actually the formula is H3PO4, which is when 1 mole of the phosphoric acid dissolves in the water, it will give 3 moles of the hydrogen ions and 1 mole of the phosphate ion. So it is actually a triprotic acid. Okay, next one. Also, this is also the same questions. Which pair of the acid is classified correctly? So we have monoprotic acid and diprotic acid. So let's look at the diprotic acid. So actually the answer is D, because we only have sulfuric acid as our diprotic acid among these 4 choices. So basically the answer would be D. Okay, next question. Diagram 3 shows the reactions between the solid calcium carbonate and the glacial ethanoic acid. So glacial actually means it is pure. Means that this is a 100% ethanoic acid. So this is the setup for the reactions between the sodium carbonate and the glacial ethanoic acid. And we have this lime water. So for information, this lime water is actually wants us to test the presence of the carbon dioxide. Means that this reaction is actually expecting the release of the calcium or the carbon dioxide, and when there is the presence of the carbon dioxide, the lime waters will turn cloudy. Okay, let's look at the question. No change is observed after a few minutes the experiment is carried out. What should be done in order to turn the lime water cloudy? So this is troubleshooting. We want to do for troubleshooting, which is why the reaction does not occur. So let's look at the options provided. So A, shake the mixture vigorously. No. B, add the distilled water to the mixture. If you add the distilled water into the mixture, you actually is diluting, or we can say you are lower the concentrations of the ethanoic acid, CH3COOH. So you are actually lowering down the rate of reaction. So this is not a good choice. C, replace the calcium carbonate with the magnesium powder. The reason is why this is not accepted is because when you replace the calcium carbonate with the magnesium powder, actually you are not getting your CO2, because calcium carbonate will then react with the ethanoic acid to form the salt, which is CH3COO 2Ca with the water and carbon dioxide. So when you replace the calcium carbonate with the magnesium, actually you are not getting this CO2. So this is not an ideal way also. So D, substitute the granule calcium carbonate into the calcium carbonate powder. So this will be the ideal answer, because granule is actually like, it has a very low total surface area. So when it comes across, or when it in contact with the ethanoic acid, it will actually not produce much reaction, because ethanoic acid is actually also a very weak acid. So when you turn this granule into the powder, which has a higher total surface area, and when it in contact with the weak acid, which is the ethanoic acid, it will give a better result of the reactions. So this is what granules means that it has a bigger size. So when we have bigger size, automatically we will have a lower total surface area. Okay, next question. What ion is produced when the hydrogen ion combines with the water molecule? So we need to know that the chemical formula for hydrogen ion is H+, and then water molecule is H2O. So we actually know that, or you need to know that, water molecule is actually having the electron, and then this hydrogen ion is actually having an empty orbital. So means that it has no for hydrogen ion, it has no electron at this orbital, but hydrogen, it has lone pair of electron. Okay, so it means that if I have electron and you don't have electron, I can donate you electron, right? I can give you this electron to you, and then we will form a bond. So this bond, and you will produce a molecule known as the hydroxonium ion. This is a classic example for that, how the dative bond is formed, or we say coordinate bond. So actually the answer would be B. So you kind of like, you will get the solution, the chemical formula, which is like this. Okay, let's say so you will get the hydroxonium ion, which is having the structure like this, and then left one electron lone pair of electron, and this is your hydroxonium ion. Okay, next question. Which of the following shows the acidic properties? So if we want to find the substance that has the acidic properties, means that it must be acid. So let's look at the options one by one. So A, ammonia gas in water. For information, ammonia gas is a weak alkali, so it is not the acid. And then B, hydrogen chloride in methylbenzene. Okay, methylbenzene is actually a organic solvent. So when this hydrogen chloride is in the methylbenzene, it will exist as the molecule form. Means that it presents like this kind of structures when it dissolves in the methylbenzene. So it will not give out the acidic properties. And one more thing I want to mention is that for acidic properties, for a substance to show its acidic properties, the acid must dissolve in the water. Why? To produce the hydrogen ions. So in this case, we are not going to find for molecule. We want to get the ions form actually. So next, C, sulfur dioxide. Sulfur dioxide is also an acid, but since it also present in the organic solvent, since it also dissolves in the organic solvent, so it will also exist as the molecule form. So we will not get the acidic properties when we test the solution with the litmus paper. So the answer would be D, which is the chlorine gas, as we know that the chlorine is a halogen. So when it dissolves in the water, it will present as the ion form and produce the hydrogen ions. This chlorine gas is actually water, so it can dissolve in water to give the acidic properties. So the answer would be D. Okay, next question. Which of the following substance is acidic? The answer is carbon dioxide, because carbon dioxide is slightly acidic. And then for B, potassium oxide is actually a metal oxide, which is the alkali. And then we already discussed for ammonia, which is it also is a weak alkali. Meanwhile, for sodium hydroxide, it is a strong alkali. Next question, which of the following substance is acidic? So the answer is sulfur dioxide. And because sulfur dioxide is actually very common involved in the formations of acid rain. Because our factories usually will emit the waste gases such as carbon dioxide, CO2 or CO, and this sulfur dioxide is the main components that can found in the acid rain. So A, B, and D is also the weak alkali as what we discussed as for the above question. So I think I will just stop here, and I will see you in the next video. Thank you.